find the values of a and b if the limit x tends to 0, a sine square x plus b log cos x upon x raised to 4 is equal to minus half. So we have to find the values of a and b provided the limit of this function is given finite. This is finite. So let's find the values of a and b for which the limit is finite. Solution. The given limit x tends to 0, a sine square x plus b log cos x upon x raised to 4. If we put 0 instead of x, we will find that sine 0 is 0, so this is 0. Cos 0 is 1, so log 1 is again 0. So the numerator is 0 and denominator is obviously 0. So the given limit is in 0 by 0 form. So we use L'Hospital rule by L'Hospital rule we have this limit is equal to the derivative of numerator function and the denominator function. So the derivative of numerator function will be a times derivative of sine square x, so which will be a 2 times sine x and by chain rule cos x plus derivative of this b into 1 upon cos x into by chain rule this will be minus sine x upon derivative of x raised to 4. So this will be 4 times x cube. Let's simplify this. Limit x tends to 0. We are simplifying this. I am not putting this limit into the function. I am just simplifying it. So this will be a times, if you observe, this is a formula of sine 2x. This minus will appear here as minus, and this will be b times tan x upon 4 times x cube. So this is how it looks after simplification, and then I will put x is equal to 0 everywhere in these functions. So sine 0 is 0, tan 0 is again 0, so numerator is 0 and denominator is 0. So this limit is in 0 by 0 form. Again, by L'Hospital rule, we will differentiate again the numerator and denominator. So this will be equal to limit x tends to 0. The derivative of this is a cos 2x into 2 minus b times derivative of tan is sec square x upon the derivative of 4x cube will be 12 times x square. Again I will put x is equal to 0 in numerator. So cos 0 is 1. So this is 2a minus b sec 0. Sec 0 is 1. So sec square 0 will be 1. So b into 1, this is b, upon 12 0. So this is 0. So what I noticed that this is infinity, but it is given that the limit of this question is a finite number. So to have a finite limit, it must be in 0 upon 0 form. So for that purpose, I will take the numerator to be equal to 0. So which implies 2a minus b must be equal to 0, and this relation gives me b is equal to 2a. I will substitute this in the above limit. So this becomes limit x tends to 0. So 2a cos 2x minus, so this is 2a sec square x upon 12x square. Then I will again check by putting limit into the numerator and denominator. Then I will find that this is in 0 by 0 form. Again using L'Hospital rule, I have limit x tends to 0. The derivative of this is minus 4a sine 2x. Derivative of this minus 2a as it is, and the derivative of sec square will be 2 times sec x into derivative of sec, that is sec x into tan x, upon derivative of the denominator will be 24 times x. Now I need to simplify the numerator, and after simplification I will have limit x tends to 0 minus 4a sine 2x minus 4a sec square x into tan x upon 24x. So let's check it again by putting x is equal to 0 in the numerator, and it will become sine 0 is 0, tan 0 is 0, so this everything is 0. So this is again in 0 upon 0 form. So it's again in 0 upon 0 form. So again by L'Hospital rule, I need to differentiate one more time. So this will be limit x tends to 0. Derivative of this will be minus 8a cos 2x minus 4a, and I need to take derivative by u into v rule. So by u into v rule, sec square x as it is, and the derivative of tan x is sec square x plus tan x as it is. Now the derivative tan x as it is, and the derivative of sec square is into 2 times sec square x tan x upon 24. Now let's put limit x is equal to 0. So what I am left with is, when I put 0 over here, so this is cos 0. Cos 0 is 1, so this minus 8a is there, minus 4a, and sec 0 is 1, so this is 1, this is 1, so 1 into 1, so this is 1, and tan x is 0, so this is 0, everything is 0, so plus 0 upon 24, so which is nothing but minus 12a upon 24, which is minus a upon 2. But the question was limit x tends to 0, a sine square x plus b log cos x upon x raised to 4 is given as minus half. So this limit and this limit should be equal, so which implies minus a half is equal to minus half, which gives me a is equal to 1. And the relation between a and b, it is this. This gives me b is equal to 2a, which implies b is equal to